Hi, everybody. It's exciting today to be here with Pete, who's my co-author from the tinyML book. And we've got a British invasion for you today. And Pete's going to be talking about his amazing new company, Useful Sensors. Um, but before that, we're going to go through a few slides to tell you about our amazing sponsors and partners at tinyML Foundation. So their names are AIZip, Analog Devices, Aeon Devices, ARM, DeepLight, Edge Impulse, Emza, PhotoHub, Greenwave Technologies, Gravetti Inc., IBM, Imagimob, Itemis, ClickerTech, Microsoft, Nota AI, NXP, OctoML, Prophecy, Kixo, Qualcomm, Reality AI, Rexen, Renesas, SAP, Seed, SensiML, Silicon Labs, Sony Semiconductor Solutions Corporation, ST, Stream Analyze, Synaptics, SynSense, Syntient, and TDK InvenSense. We really appreciate your sponsorship. It's what makes all of this possible. I'd also like to point out our amazing tinyML meetup community and LinkedIn community. We've got thousands of members in each one. So if you want to either discuss tinyML with people in person locally in your community, sign up to a meetup group and go along to an event, or even you can create your own if there's nothing locally. And if you want to chat online, we have our tinyML community on LinkedIn. We also have this amazing tinyML YouTube channel, which is where all of these videos go after they've been presented. And at this point, we have 492 videos, which is mind-blowing. I mean, I remember when we did our first little meetup group in Silicon Valley a few years ago. At this point, we've got hundreds of videos on all sorts of topics in tinyML, thousands of subscribers. If you head over there and hit subscribe, you'll get the videos in your feed as they come up. Our next tinyML Trailblazers series is coming up soon, and that's going to be live online on November 9th, 2022 at 8 a.m. PDT. And it's hosted by Chris Rowan and is going to feature Massimo Banzi from Arduino, who's an amazing speaker, awesome person to listen to. So I really recommend checking that out. And our next tinyML talk is coming up on Tuesday, the 22nd of November. And that's from Arindam Sanyal, who's assistant professor at Arizona State University. And the topic is analog tinyML for health management using intelligent wearables. And that starts at our usual time of 8:30 a.m. Pacific. If you are interested in suggesting a talk topic, we're always very excited to hear from you. So please just drop a line at talks@tinyml.org and suggest your idea. And yeah, that would be really good. So a quick intro for Pete, if you don't know him already. Pete's the CEO of Useful Sensors, which is a startup building AI interfaces for everyday objects in a privacy-secure way using tinyML. He was previously the founder and lead tech of the TensorFlow Lite Micro embedded ML library and sold his previous company to Google in 2014. And he is the author of the tinyML O'Reilly book. So that's my cue to hand it over to Pete. Thank you, Pete.
Awesome. Thanks so much, Dan. Yeah, from one author of the tinyML book to another. Yeah, so thanks everyone for joining me. I'm going to be talking about what we're doing with Useful Sensors, but to understand what we're doing, I kind of wanted to go back to the beginning, at least for me, with tinyML, and how I first came across tinyML. And the key thing with this, this sentence, "How did I discover tinyML?" is that, like most British people discovering something, it's actually something that a lot of people already knew about. I was just one of the people who actually helped publicize it, and this was my first encounter with this idea of running machine learning on embedded devices was back in 2014. when I just joined Google, and I joined Google with a startup that was doing machine learning on phones. And I thought that was pretty wild at the time, because machine learning was pretty much, as far as I knew, something that mostly happened in the cloud. So doing it on a device as small as a phone seemed, pretty unusual. Um, but when I actually got to Google, one of the first teams I met and one of the first people I met was actually Raziel Alvarez, who's now at Meta. But he was, and his team were some of the pioneers in the tinyML area with the OK Google. And sorry if your phone just went off, if you're on Android. We would actually call it OKG in meetings to avoid that problem. But the wake word model, the model that kind of sits there running on your phone when the CPU is off, listening out on the microphone for somebody to say that phrase, so it can then wake up the CPU and respond appropriately to anything that comes in. But that was running on all these funky microcontrollers and DSPs within phones, because the main CPU had to be turned off. And what really blew my mind was the fact that they were just using a 30 kilobyte model. And I was feeling pretty, like we were pretty clever, because we'd figured out how to squeeze down models on the phone to like a megabyte in size. So meeting Raziel and his team and discovering that they were able to do useful stuff in just 30 kilobytes really was pretty mind-blowing for me. And it really got me thinking, wow, if we can actually, if somebody can actually do something as useful as speech recognition in this tiny footprint on these really cheap, low power microcontrollers and DSPs, I wonder what other problems we can solve. And then I think it was maybe a year or two after that that I first met with Evgeny, who is the founder of the tinyML organization. But at that point, I met him through his work on Qualcomm's Glance module. And for those of you who aren't familiar, this is a really neat little piece of hardware that includes a camera and some processing power in one little package for just, sort of single digit milliwatts sort of power usage. And it has a whole bunch of things like, facial algorithms and other really useful pieces of intelligence sort of baked in. And when I saw that, I again was sort of like blown away, because I realized, wow, you can actually integrate not only the smarts but also the the sensing capability, and then really make it much more easy for people to pick up and integrate. So those two moments together made me determined to explore this area and really try and understand more about what we can do with this stuff.
Also, we had a quick question come in there from Cliff, which is, why aren't you using the Glance module for useful sensors?
Well, that's a great question. One of the challenges was the Glance module is such a pioneer. A lot of it was built before the modern deep learning approaches to models were available. And Evgeny can correct me, but it's using much more classical approaches to doing things like face detection, and some of the other stuff that's available. You can find out more on the website, but it didn't have the programmability that I needed to be able to run all the models that were coming up. But yeah, so that's why I just didn't use the glance module off the shelf.
Awesome, thank you.
No problem. That's a great question. Yeah, because I'm saying how awesome it is, and so with that in mind, the story behind TensorFlow Lite Micro was, and Dan was, a key part of this. I was able to work on TensorFlow and TensorFlow Lite, getting it running on billions of phones for my first few years at Google, and that got me enough goodwill to set up a small team to try and follow that idea of like, wow, okay, what if we could make it easier to run a whole bunch of models on these tiny embedded devices. And I had to put a small team together. We worked for about a year. At the end of it, we were able to release the first version of TensorFlow Lite Micro, which the key thing about it is that we stripped a lot of stuff out, so it's able to run on bare metal, as well as on most RTOSes, and hopefully it runs on most 32-bit microcontrollers and DSPs now, and we have a lot of optimizations that have been contributed by people like ARM and Qualcomm and Cadence and Siva and Synopsys, and I'm sure I'm missing some of the companies we've worked with, but the short story is, it's definitely helped me be able to run models across a whole bunch of these different chips in a fairly efficient way. So that was one of the goals I really wanted to achieve. Worked with Dan on the O'Reilly tinyML book. We built a lot of documentation and examples in the team. I stayed in touch with Evgeny. We collaborated a lot, and kicked off the first tinyML summit together. I'm very happy that Evgeny is now taking most of the organizational work for tinyML, but it was really great actually getting that kicked off. And I've been sort of trying to popularize this by putting on courses. If you search for edX tinyML, you'll actually find a free online course that you can take to understand embedded machine learning, kind of from the ground up. And so, this is kind of the progress today, and this has been great. Like we saw in the slides at the start, there's been an incredible community built around this, this idea of tinyML. And it's been fantastic to see. I think the edX course last time I checked, it had over like 40,000 people take it, which has been, which is, again, I keep saying mind-blowing, but there's that really, all of those numbers that I see really are pretty amazing. And it's wonderful to see this community. But this has been fantastic to see, but it's not we're still not we haven't taken over the world yet. We have this massive grassroots kind of groundswell of people who are interested in this, it kind of, in some ways, it reminds me of, I'm old enough to have sort of grown up during the 80s and seeing kind of personal computers, especially like home computers, being adopted and people doing all sorts of really neat stuff with them. But it hasn't really broken through into the mainstream commercial world. Um, and I think Stacey Higginbottom uh, had a really good take on this after the last tinyML summit, where she's been a massive somebody who's super interested in this space, a really good supporter, but she really called out the fact that we have all of this technology, and especially at the last tinyML summit, we had more technology than ever, but we had way more technology than customers. We didn't have all the use case. 348 attendees. That's fantastic. But a lot of us were people who were building things, rather than people who wanted to buy the things that we were building. And that really is something that I was driven to dive into this world because I was really struck by all of the amazing things that we could actually use this stuff for. It is a fantastic technical challenge. It's honestly really fun engineering, trying to fit everything into a very sort of constrained memory space. But I really wanted to be able to just enable things that seemed like they should just exist to me, like an interface where you could look at a light and say on and have the lights come on. That seems way more natural to me than having to do and again, sorry for setting up people's devices off, but Alexa living room lights on. That just feels like a way of interacting that it's not how we talk to people. I don't say sort of Dan, chair by desk, sit. It's or other things like just being able to kind of control TVs using the wave of a hand, or have your TV just pause when you get up to get a cup of tea off the couch. Like that should just work. But when I went to talk to people who make light switches, or people who make TVs, or people who make appliances, and I would tell them about all of this wonderful code and documentation and courses and books and conferences, and you can just get started for free. It's it's fantastic. And usually at the end of that pitch, they would just kind of like look at me and sort of scratch their heads and say something like, look, we barely have any software engineers, they're all very, very busy. We definitely do not have a machine learning team. Can you just give us something that gives us a voice interface, or can you give us something that wakes up our TV when people sit down in front of it? Or they'd have sort of very clear product features that they wanted to enable, but they really did not want to get pulled into a science project. And to be clear, there are some manufacturers who are who have kind of grabbed the opportunity and have really invested in working on some of this stuff. I would look at people like Keurig, who are doing really amazing sort of computer vision stuff. And but most of the people I talked to in this kind of manufacturing space just didn't have the ability or the will to put a lot of time into figuring out how they could do something themselves. So after hearing that for enough times, probably over the course of several years, I really started to actually take it on board that this was, a problem that we would need to think about solving. And so I decided to leave Google to try and build something. And some people have asked me why I left Google to do this. Google's been fantastic. It's been an awesome place to kind of build TensorFlow Lite Micro, and they've been super supportive about open sourcing. But what I realized was that I needed to be able to release some hardware to give people the complete solutions. And for any big company like Google, it's a massive risk to release any hardware with their name on it. It's a really big reputational risk. And I really wanted to be able to experiment by releasing hardware. Like, it's way easier to release software or models because that's just a much less risky thing for any big company to do. I really wanted to be able to experiment with doing hardware. And so the two big design principles that I started with, based on my experiences working with these manufacturers, were one of them was that the way that ML capabilities were provided to manufacturers had to be in a very familiar, easy to pick up form. And I knew that these manufacturers were able to take things like, pressure sensors or temperature sensors or even accelerometers and integrate them into their system. Their engineers, their whole organization was very familiar with this idea of, hey, we've got a sensor, we're going to feed that into the code that we run on our microcontroller, our business logic, and use that to help control our products. So if we were able to smuggle in machine learning capabilities in a form factor that looked a lot like a sensor, I was hoping that that would give us a really easy way for people to pick up these kinds of devices. And the other thing that was really important for me from the engineering side was trying to make sure that we're actually giving privacy guarantees, and not just privacy guarantees that we're claiming, but things that other people can check. So trying to build our systems with privacy designed in, so that there's a lot less risk to adding all of these cameras and microphones to everyday devices. Because it does scare me, this idea that cameras and microphones are getting way cheaper. There's going to be all of these ways that they can be really useful. But if we're not careful, we'll just end up with this world of devices that are open to hacking and can be used for spying on us, or either by malicious attackers or even organizations like governments and things like that. So it was really important to actually come up with something that was private by design. And
so, quick audience question
yes,
here, if that's okay. So what are the technology or market trends that will make tinyML a commercially compelling technology? So some of the examples the question gave were semiconductors, processes, algorithms, architectures. And when do you anticipate all of this coming together? In a year or 5 years or 10 years?
Well, my take is actually that all of the pieces are there. What's really been the gap and the chasm that's been hard to cross is that it's very unfamiliar to most of the people who are actually building um, the appliances and consumer electronics and vehicles and everything else that's kind of in our everyday world. So they both don't know what's possible, and they don't have easy access to ways to experiment with these new capabilities. I think that especially some of the new accelerators that are coming in for embedded devices, things like the U55 from ARM, and then there's similar devices from a lot of the other hardware manufacturers as well, the chip manufacturers. Those are going to help, but honestly, I think that a lot of the gap is that the software is too hard to use. And I think Edge Impulse is a great example of how making the software easier to use has opened up all of these doors and got, I think, they're worth calling out as doing an amazing job actually helping people get up and running. And they're also a great example of like all of the pieces are already there. You just need some way that the actual people who are building these things have a much easier way to access them.
Oh, thank you, Pete. That's very kind. And yeah, I mean, I completely agree that all these pieces are here, and it's about awareness of what's possible and accessibility. Um,
Yes.
we're in the right place now. So a couple of more questions, but I think I'll pick one of them and then we can address the rest at the end. So I like this one because I know you've got a good answer. Engineers expect proper data sheets for every sensor they use in their products. So have you started writing data sheets for your sensors?
Yes, and the sales team have also asked me this question, and there are a bunch of things that we can write data sheets, put examples on the data sheet for, like energy usage, like the field of view of the camera, like the actual physical size of the board. But there's a lot of the things that you actually kind of want to know, like, hey, how well does it perform in low light? Because these are AI models and they're very kind of idiosyncratic, like there's so many different factors that can affect how well they actually work. It's actually pretty hard to write reproducible or to create reproducible experiments to measure some of these properties that you actually want to be able to measure. Like, for example, you imagine you can kind of set the lighting conditions so that they're kind of controlled in a room somewhere. But then really what you want is for somebody to walk in and to find out, okay, it actually it spots Dan's face at 2 meters, but it does not spot Dan's face at 3 meters. But what if Dan has a pesky, mustache, and that actually that particular model has trouble with mustaches? Then that's actually going to make the results very different than if I came in without a mustache and it was actually able to recognize me much better. So there's a lot of trouble coming up with experiments that will get the same results tomorrow that you get today, which is kind of one of the things that you want to have objective measurements in a data sheet. Now, that doesn't mean we're giving up, but it does mean I'm actually trying to work with people like Professor VJ Reddy over at Harvard on coming up with experimental protocols and designing experiments where we can actually try and capture some of the properties that all of these kinds of sensors and models exhibit as end-to-end systems. Because really what we need is something that is you can use to compare between devices. Like, you'll want to know, hey, which device does better at recognizing faces in low light? And unless we come up with some proper, people running the same experiment in the same way on two different sensors at two different times and getting kind of results that can be compared to each other, a lot of the numbers that we could put on a data sheet aren't going to make much sense. And that honestly, that's partly an excuse because we've just had trouble measuring a lot of these things. So I would love to hear from you, though, if you have particular things that you need for your application, particular properties, especially. So drop me an email at pete@usefulsensors.com and tell me, hey, this is the thing that we're really missing from the data sheet. And that will help us prioritize, the kinds of experiments we're going to be able to run to measure these things.
Awesome. Thank you, Pete. So we've got a ton of questions coming in, but I think we should move along and we'll get to these at the end because otherwise it just keeps on going.
Yeah. And I'll haven't got many more slides, so we should be able to get to the questions pretty soon. So as you might know from seeing our sort of product launch, what we came up with to solve the no code sort of, being able to really grab these devices and start using them immediately was making the interfaces the same interfaces that you use for sensors that you're connecting to your system. So we have things like the person sensor, which is the first example of this. It has one pin that goes high whenever people are detected. So that's really kind of the no code part, is you can actually wire this into an analog circuit and, for example, wake up a kiosk or a booth device when somebody kind of walks up close to it. You just kind of drive that interrupt pin, or you could even use that in an analog circuit to light up a light when somebody walks nearby. Now if you want more information, like where people are, or even things like facial recognition, identifying people, then you use the I2C interface to actually access that kind of information. This is a little example. Some people asked me what that substance was that was behind the sensor. The sensor itself is the little square with the image sensor on it. That's actually blue tack because that's what I use to attach the chip to the stand, and it drives my team, who are much better actually assembling hardware than me, crazy to see this. But I'm trying to use it to encourage them to come up with something better. So this is you can back order these now. They're currently out of stock on SparkFun, but we have 2 new batches coming in over the next few weeks, so we should be able to meet those orders soon. And this does kind of what I described earlier. So we've got hopefully the convenience for manufacturers, but what about the privacy? And a lot of this came from my frustration of working on speech at Google. And one question that came up a lot from family and friends was, hey, I was just talking to my friend about Tunisia, and I the next day I got a bunch of ads for holidays in Tunisia. Is Google listening in to my conversations? And I was able to say, hand on my heart, no, because I've worked on that code. We just don't even have the technical capability to do that in these microcontrollers, and in the code that's in there. But I can't prove that to you. I can basically say, trust me, but what if you don't trust me or Google? How can anybody else go in and actually check these claims? So what we've done with the the person sensor and the other ML sensors that we're planning on building is try to make it possible for third parties to actually check that there's no API, there's no way to actually get hold of the original image information, that it remains on the device, on the hardware module, even if the rest of the system is hacked, or you don't trust the people who are making the product 100%. We're aiming to basically make sure that it's as firewalled as possible, the original image data, and the only thing that you can get hold of is kind of the metadata, the things like, hey, there were a bunch of faces here and they were in these positions, as opposed to actually being able to see the raw images and get any access to those. And really trying to build it so that we hope that people like Underwriters Laboratory, Kudelski, other people who check security and privacy on IoT devices have hopefully a fairly straightforward way of confirming that what I'm saying is actually the way things work. And so you can check out, this was a fun Halloween project that I adapted from something that somebody in our community did, that you can find on Hackster. You can find a whole bunch of projects there. It's been great seeing these devices go out into the world, and people pick them up. I love the maker community and their creativity. And we've been working a lot with a bunch of the manufacturers that I discussed as well. It's been really good to see that this does seem to have helped both makers and some of the commercial manufacturers do interesting things. So I promised no code. Technically, you can do no code if you just want to link up the, hey, there's a person nearby, light up a light. But if you actually want to get the detailed information, this is kind of the example of doing that. And really, it's, you do some I2C setup first, and then you call that person sensor read function that gives you an array of structures telling you about the faces. So hopefully that's not too off-putting. And we're building more sensors. This person sensor was just kind of the start. We're really interested in doing things around hand gestures. Seems to be something that's pretty popular. I would love to be doing more stuff around voice interfaces, sort of next year. And then there's a whole bunch of stuff that I would love to work on that, I don't have slotted into the roadmap yet, like detecting text in images and just doing like kind of an ADC for the real world. But anyway, I could talk about all of that stuff for ages, but I would love to take this chance to take some of your questions.
Awesome. Thank you so much, Pete. And I love that thought of an ADC for the real world. This is a really cool thing that's happening right now. And there's loads of really good questions. So I'm going to kind of pick at them in semi-random order, but maybe start with some questions that people had at the beginning, in a very general sense around, like, what is the best place to find sensors generally? Like someone's interested in building an e-nose sensor. What would you recommend at a nominal budget? There's someone else who's interested in monitoring cassava growth, and what type of sensor would be appropriate there. What are some good resources people can use to understand what sorts of sensors are out there in the first place?
That's a really good question. Honestly, it's something I've struggled with myself because, I don't know the sensor world that well. And I don't remember, do you remember, Dan, there was somebody who built maybe an Edge Impulse project around like eNose stuff, was it?
Yeah. It's there's I can find the link and
Yeah,
post it in the
if you
chat
find the
while you're
link,
talking.
because yeah, that was a case where I was like, oh wow, you can actually do, smell detection using a sensor. I actually didn't know that before I came across the Edge Impulse project. And I think if I remember correctly, it was actually looking out for different kinds of pneumonia on people's breath.
Ooh, there's a few different ones. So the one I was thinking of was building an artificial nose for smelling different types of food,
Oh yeah, and so yeah, that
different whiskey.
yes, yeah, which is also a very important important area. So yeah, I've actually tended to discover a lot of this stuff through the community. So going to places like Edge Impulses forums, or places like the tinyML forums, or Hackster, um, and just actually kind of asking the community. Because again, like the smell one is one that I had not run across before. Now the cassava one is really interesting because I think both me and Dan, while we were at Google, worked on, helped out on a project that was actually using computer vision on phones to recognize cassava diseases. So in a lot of cases, like computer vision and using image sensors is sort of my default go-to for a lot of things, because even places where you might not think it would be useful, like in doing sort of speech recognition, you can actually do lip reading to help augment what you're getting from the microphone. And also in the speech case, you can actually use gaze. Is somebody looking at me, to tell if to help augment things like, and get rid of things like a wake word. So the cassava use case, I would actually look up Plant Village, and there's a bunch of projects that they did on computer vision that might be quite helpful.
Awesome. Thanks so much, Pete. So some other questions. There's so many different questions on different topics. It's hard to pick which ones to go with. So let's go with some very specific ones. So so this is from George. Hi, Pete. Thank you for the insight. Very interesting. Can you program a useful sensor device to change slightly the model that it runs? For example, if you get a person sensor, but you want to retrain the model to operate on images with different resolutions.
So no, it's the short answer. And what I would actually recommend for that is looking at solutions like Edge Impulse. If you like, one of my favorite devices right now is actually the Pico 4ML board from RGCam. If you look that up, because that has a Raspberry Pi Pico together with a small screen and a camera and microphone built in. And that really lets you build your own models for this stuff. Now, a bit longer term, and I haven't talked about this, properly with Edge Impulse, but I would love to sort of set up something where you can actually build a model using Edge Impulse, with their fantastic tools, and then actually just order that model baked into a bunch of sensors. And part of the reason, the main reason that we don't allow programmability on our sensors is we want to be able to have some guarantees about the privacy side of things. And the more programmability we offer, the bigger an API surface we have and the harder it is for us to actually, and especially for third parties, to verify that people can't put something malicious on there that will surprise the end user.
Awesome. So first up, yeah, we're definitely here for that, and
Yes.
be really excited to get that integration going. And then your answer leads in really well to another good question, which is, do you plan to release your code to some of the serious security research groups to make sure there are no exploits possible to compromise raw data?
Yes. We're working with we're part of this is like trying to find groups who are especially commercial groups who are able to wrap their heads around like the intersection of ML plus embedded. We're working with, I think I mentioned Kudelski. They're very big in the IoT kind of security space. We want to, one of the big questions, one of my big questions is, nobody's using I squared C as a security kind of, barrier. So there hasn't really been much point in fuzzing and, trying to hack into I squared C by sending weird, inputs and messing around with clocks and things like that. So I'm expecting that there will be some issues there. So we're interested, I'm interested in, talking to anybody who's working in this space, because I'd like to kind of see if we can set up some standards for, hey, this is what it means to actually check the security and the privacy of some of these devices.
Awesome, thank you. So we got a bunch of people are asking about when will the devices be back in stock. So Pete actually answered that question while we were waiting for the talk to start, and I typed up the answer, and it's in the answered section of the Q&A tool.
I will just offer an apology too. Part of this is, I could just blame general supply chain issues, but honestly, a lot of it is, I'm a software person and I'm just figuring out how to actually build hardware. So yeah, apologies for the delay. We're trying to get them out to everyone as soon as we can.
So yeah, there should be more hardware in the next couple of weeks. Was the kind of TLDR there, but there's a longer answer in the Q&A. Awesome. So another question. So since most of these problem solutions are changing because of new models and networks being discovered, does the company support the idea of updating the sensors models? Is that something that's possible or desirable?
No. Is and again, this kind of comes back to the this partly comes back to the privacy side. We really want to be able to, in my ideal world, I would like to ship these with the code in ROM, so that the thing that has been checked by security researchers is sort of set in stone, and is very, very hard to alter, making it harder to hack. This I know as an engineer myself, this can be a bit frustrating because you sort of know, hey, the hardware is there and it would be possible to update this stuff. But for a lot of the manufacturers we work with, for them, having the ability to update is actually in a lot of ways more of a liability than a plus, because if there's some security flaw in like the Bluetooth stack that's discovered like 5 years after they released their dishwasher, and that means that anybody can suddenly update software and effectively hack into their devices, that's suddenly something they have to deal with. And these devices have long lifetimes, 10, 20 years. The thought of, being responsible for updates or having the ability to update that could be abused by somebody else is kind of pretty, daunting for them. So I'm hoping there's a lot of other alternatives if you do need that updatability. But we're really sort of aiming at this sort of just you use it off the shelf. It does one thing, it does the same thing, 10 years later that it did when you sort of bought it. But I'm happy to discuss, there's lots of other tools you can use if you do need that level of flexibility.
So that's a kind of second question someone's asked, which I think is an interesting follow-on. So what's your take on model drift with respect to the fact that these are fixed weights?
Yeah, so and especially, the classic example of this is, if we'd launched the face detector in 2019, then suddenly in March 2020, it would have to deal with, oh wow, there's a lot of people wearing masks, and that that would definitely have made it less less effective. So I see almost, like that sort of domain drift as being a challenge for a lot of this stuff. Part of what we're trying to do is focus on things that we're hoping don't change all that fast, things like human body shape, things like speech, accents and languages do change, but hopefully over the course of sort of decades, sort of longer than the expected lifetime of our sensors. So I think a common theme is like we're actually trying to really limit the scope of a lot of what we're doing in order to make it a lot simpler for people who don't want the flexibility to sort of pick up and use. Now we may end up kind of actually going too far in that direction and actually having to say, oh, we can't update the code, but you can update the model weights or something like that as we sort of discover how people use it. But part of what we're doing at the moment is just saying, okay, how much can we simplify this thing? Because you don't update an accelerometer with, sort of new functionality, during its lifetime. And if we can make it as much of a just thing you get off the shelf like an accelerometer, that would be our goal.
Awesome. So I think, have time for one more question. I'm very sorry because we've got loads of questions, but what we do usually is post the questions that are left over on the forum afterwards, and Pete can dive in and answer any if he has time. Yeah, I think I don't know which question to ask. So a question I think is a good one is useful sensors a hardware business primarily?
That's a tough question, and it's one honestly that a lot of VCs we've talked to have asked, because hardware companies are notoriously hard. And I'm fundamentally a software person who's sort of like dabbled in hardware. One answer to that, I guess, is that we're not building, like, we're using entirely off-the-shelf components. We're just assembling them and adding our software. So, as you can tell from the delays in shipping, we are reliant on hardware and we are having to do some hardware manufacturing, but it's a very high level of just kind of like gluing existing off-the-shelf components together to get, onto a PCB and then flashing our software. So I'm hoping that we're kind of most of what we're offering that's new is in the software and in the models and in the AI side. But I guess we're a weird thing that we don't have a good name for yet.
Oh, that's always the most exciting way to be, I think. Oh, awesome. Thank you so much, Pete. And thank you so much to our audience. So many amazing questions. You can really tell how excited people are about a topic by how many questions people have. And I think this is the most questions I've ever seen in one of these talks. So I think you're onto something there. I'm going to request remote. Oh, I already have remote control, so I can go through these exit slides. But yeah, there'll be some discussion on the forum after the talk. The link will be sent out, and Pete's email is here, pete@usefulsensors.com. So thank you so much, everybody. Thank you so much to all of our amazing partners and sponsors for helping support these talks and all of the tinyML community. And I specifically like to call out our executive strategic partners. We've got ARM AI, who are powering tinyML innovation. Edge Impulse, the leading development platform for Edge ML, which is where I work. Qualcomm AI Research, who are advancing AI research to make efficient AI ubiquitous. Sentience, who help you make Edge AI a reality by accelerating your edge compute. And then our platinum strategic partners, DeepLight, fastest video analytics solutions on ARM CPUs. ClickerTech, global IoT solutions. Reality AI, tinyML software that covers the full engineering lifecycle. Renesas, who's enabling the next generation of AI-powered solutions that will revolutionize every industry sector. Sony Semiconductor Solutions Corporation. And our gold strategic partners, Analog Devices, where what if becomes what is. PhotoHub, making over-the-air firmware and ML model updates simple and accessible. Microsoft, NXP, together we accelerate the breakthroughs that advance our world. Seed Studio, deploy tinyML into the real world with plug-and-play ML. SensiML, the right edge AI can make or break your next smarter IoT product. ST Microelectronics provides extensive solutions to make tiny machine learning easy. Synaptics, why can't I talk today? Synaptics, engineering exceptional experiences. SynSense, who builds sensing and inference hardware for ultra-low power embedded mobile and edge devices. And then our silver strategic partners that we've seen in our first slides. Our next talk is going to be on November 22nd with Arundam Sanyal, who's assistant professor at Arizona State University. And it's on analog tinyML for health management using intelligent wearables. So that's at 8:30 a.m. Pacific time. And like I said before, if you have any talk ideas you'd like to participate, please just drop us an email at talks@tinyml.org with your idea. So finally, we just have our copyright notice. So that's it from us today. Thank you so much to everybody who's joined. And thank you again for Pete